Welcome to today's numeracy tutorial. Our learning objective today is to identify and count in tenths. So far we understand that any whole amount can be split into equal parts, and we can show this by writing fractions. A fraction is a special number that is made up of a line and two parts. It shows the number of parts out of a whole. The numerator is the number that goes on top of the fraction line, and the denominator is the number at the bottom of the fraction line. Today, we will continue to develop our mathematical understanding of fractions by understanding and learning how to represent whole amounts as tenths. We will also get experience of counting in tenths so that we can complete number patterns. As always, we'll get ready for our lesson with a 5-question brain gym. Get ready to warm up. Here are your 5 questions. Pause the video and have a go. Question 1 asks, what fraction of the shape is shaded? We can see altogether there are 9 squares. Our denominator will be 9. 5 of those squares are shaded, so the numerator is 5. The fraction of the shape that is shaded is 5/9. Question 2 asks us to compare the areas of the two shapes, A and B. Area is the surface space taken up by a shape. It's the measure of the inside space of a shape. We can see that shape B takes up more space, so its area is the biggest. To answer the question, shape A has the smallest area. Question 3 requires you to multiply more than two numbers. So 2 times 5 is 10, 10 times 10 is 100. Question 4 is an addition calculation. We need to find the sum of 849 and 37. The sum of the two numbers is 886. Question 5, as normal, is your time question. Write the time in words and in digital format. We can see the minute hand is pointing to 6, so we know that it is 30 minutes past, more commonly known, of course, as half past. It's 12:30, and that's written 12:30. Congratulations to everybody that did well today. We're ready to focus on our learning objective. Building on from prior knowledge, today we are going to investigate tenths. What fractions of the flowers are blue? We can use our STEM sentences to help us. There are 10 flowers altogether. 3 of the 10 flowers are blue. 3/10 of the flowers are blue. Notice the denominator is 10, showing us how many flowers there are altogether. The numerator is 3. This is the part of the fraction that shows us the number of parts of the whole that we are interested in. As the numerator is more than 1, this is a non-unit fraction. How about we look at what fraction of the flowers are orange? Pause the video and have a think. We will continue to use our 10 flowers altogether, so the denominator is 10, and 7 of the flowers are orange, so the fraction of orange flowers is 7 out of 10, and we write this as a fraction 7/10. Here is a bar model. If I divide my bar model into 10 equal sections, then I have divided the bar into tenths. One section is equal to 1/10, 1 out of 10 equal parts. Which of these illustrations show 1/10? And can you explain why? Pause the video and have a think about that. In the first example, we have 10 equal sized circles all together, and one of those 10 is shaded. So yes, 1 out of 10 is equal to 1/10. In the second example, we again have 1 out of 10 sections shaded, but we can see that the sections are not equal. So no, this illustration does not represent 1/10. In our next example, we have a circle that has been divided into 5 equal sections. If we divide each of the sections in half, we'll actually get 10 equal sections. And as one of these sections has been shaded, well then, this does represent 1/10. In our final example, although we have two parts shaded separately, if we put them together like this, we can see that we have 1 out of 10 equal parts shaded. So yeah, this representation does in fact show 1/10. Here there are 10 equal sections, and one of the sections is shaded. 1 out of 10 is equal to 1/10. What would the fraction be if 9 out of the 10 sections were shaded? This would show 9/10. If 9/10 of the bar is shaded, what fraction of the bar is not shaded? There is 1 out of 10 not shaded, so the fraction is 1/10. Have a look at this bar model. Can you find what fraction of the bar is shaded and what fraction is unshaded? Pause the video and have a go. As 4 out of 10 sections are shaded, then the fraction of shaded sections is 4/10. The fraction of the bar that is unshaded is 6/10. Have you noticed the pattern? A whole amount broken into tenths is 10/10. We can identify pairs of tenths in a whole using number bonds within 10 as the numerators. Here the purple bar has been split into 10 equal sections. This whole bar represents 1. Using this information, what number does each of the shaded parts below represent? Pause the video and have a think. In the first example, there are 10 sections altogether. These 10 sections represent 1. The whole. 7 sections are shaded yellow and 3 sections are unshaded. We can show this on a part-whole model. 7/10 and 3/10 all together make the one whole, or 10/10. We can see that the shaded part represents 7/10. In the next example again, the whole bar has been split into 10 equal parts. 10/10. One of the sections has been shaded red. 9 parts are unshaded. Again, we can show this on a part-whole model. This is represented like so. The top circle represents all of the sections, the whole 10/10. We can see this whole fraction, or 1, has been split into 2 parts, 9/10 and 1/10, which is equal to 10/10, which is equal to 1. 1/10 is the number that is represented. This is a unit fraction. In the final representation, 9/10 are shaded. 1/10 remains unshaded. Again, on the part-whole model, we can see that the fraction pair is equal to 10/10, the whole, or just 1. The shaded part of the shape represents 9/10. Have a go at this one. What fraction of the cubes are red, blue and yellow? Pause the video and have a think. There were 10 cubes altogether, so we know that the fractions will be tenths. There are 2 red cubes, 5 blue cubes and 3 yellow cubes. So the fractions will be 2/10, 5/10 and 3/10. We can show this on a part-whole model for the 3 fractions. 2/10, 5/10 and 3/10 together make up the full amount of cubes, or 10/10. This is equal to the whole quantity of the cubes. Let's examine this word problem. We are told that 7/10 of the gummy bears are purple. What fraction could be blue and what fraction could be yellow? Pause the video and have a think. Let's have a look at this investigation together. We know that the denominator is 10, so there are 10 gummy bears altogether. So we know 7 of the 10 bears are purple. Let's just show the 7 purple gummy bears. We need to find the possibilities of the other 3 gummy bears, because the denominator is 10. Altogether, there are 10 gummy bears. Well, they could all be blue, which would make the fraction of blue gummy bears 3/10, and the fraction of yellow gummy bears 0/10, or just 0. Alternatively, one of the bears could be yellow, which would mean that 2/10 of the gummy bears are blue and 1/10 of the gummy bears are yellow. Or perhaps the fraction of yellow bears is 2/10, which would make 1/10 of the bears blue. We might even have all 3 of the gummy bears yellow, which would make the fraction of yellow bears 3/10 and the fraction of blue bears 0/10, or just 0. Our investigation has shown there are 4 possibilities for the remaining 3 bears. Here we have a 10 frame with 10 red counters. What fractions of the counters are yellow? None of the counters are yellow, so our fraction is 0. How about now though? 1 out of 10 counters are yellow, so the fraction of yellow counters is 1/10. We could show this on a bar model that has been divided into 10 equal sections and has had one of those sections shaded. How does this change if we have 2 yellow counters? There are now 2 out of 10 yellow counters, so the fraction of yellow counters is 2/10, which we can show on our bar model like this. If we change the 10 frame to show 3 yellow counters, 3 out of the 10 counters are now yellow. We would have 3/10, and a matching bar model like this. 4 yellow counters would show 4/10, and 4 sections on the bar model would be shaded like so. We can continue this pattern until we have found a full 10 frame of yellow counters. So here is a full 10 frame of yellow counters. What is the fraction of yellow counters? 10/10, or a full frame, which is equal to 1. We can show this on a bar model like this. Then if we had 9 yellow counters, well, we would have 9/10 shown. And this would be represented on a bar model like so. 8 yellow counters would mean 8 out of 10 of the counters are yellow. This is 8/10 and is shown on the bar model like this. And the pattern continues. 7 counters will be 7 out of 10, which is 7/10, and on a bar model there are 7 sections shaded. Here we have 3 ways in which we can represent tenths. We could use a 10 frame, or a bar model divided into 10 equal sections, or alternatively a number line which has been divided into 10 equal sections like this. If we have 1 counter in the 10 frame, then we show this on the bar model and the number line like this. We shaded one part of the bar model and labelled 1/10 on the first section of the number line. If we have 2 counters in the 10 frame, then notice we also count up in the sections in our bar model and on our number line. As we keep counting, we will continue to represent tenths in this way on the bar model and on the number line. We can keep counting following this pattern until we reach 10/10, which is a whole. Have a go at solving this word problem. Greg has eaten enough chocolate already today. He decides to give his last bar of chocolate to his friends. Take time to notice. He is not sharing the bar with his friends. He is giving it to them. We can see that each of his friends has some chocolate. Pause the video now and work out what fraction of the bar does each friend get. We can see the bar is split into 10 equal squares. Each friend has got some. Francesca has 1 square. That is 1 part of the whole 10. As a fraction, Francesca has got 1/10, which is a unit fraction because it has a numerator of 1. Flora has 2 parts of the 10. She has got 2/10. Drake has 3 parts of the whole, so he has got 3/10. And Leonardo got the greatest fraction of the whole. He got 4 parts, which is 4/10. We have seen that we can show fractions using bar models, part-whole models, and indeed number lines. Use the bar models shown here to help you complete the number patterns. Pause the video and have a go. Let's look at the first number pattern. We can see that it begins with 1/10 and that it increases to 2/10 and then a missing number. We can carry on examining the pattern and we notice that the pattern increases by 1/10 each time. The fraction that is missing is the third part of the sequence. The missing fraction is 3/10. Moving to the second number pattern now, we notice that the pattern this time is decreasing. It begins at 8/10, then 7/10, 6/10, then a missing number. We notice that the number sequence is decreasing by 1/10 each time. And we can see now that the missing fraction is 5/10, then 3/10. Finally, the last missing number is 2/10. If we were asked for the next number in this sequence, we can see that it would be 1/10. Let's have another go at completing these number patterns. Use the bar models to help you find the missing fractions by examining the patterns very closely. Pause the video and have a go. Let's look at the first number sequence. We can see that it is increasing. First we are given 3/10. The next number in the sequence is 5/10. We can see that that was an extra 2/10. We can find the missing fraction by shading another 2/10 on the bar model, or simply by counting on 2 more tenths. The missing fraction is 7/10. The second sequence here is decreasing. Starting at 9/10, if we count down to 6/10, we see that there is a difference of 3/10. If we count down another 3/10, we can see that the missing fraction is 3/10. We can show fractions using a bar model on a number line. Let's shrink the number line way down and then take our different representations of a bar model to show the fractions alongside this. Just like this. Can you see the pattern? As we increase each section of the bar model by 1, so the number of tenths increases along the number line. What would happen if we extend the number line? Like this? Well, we can continue to count in tenths, but notice, we would need a second bar model, as our first bar model is complete. This would be 10/10 from our first bar model and 1/10 from our second bar model, making it 11/10 altogether. Then let's add on another tenth. So we can see that's 12/10. We can continue counting this way up until 19/10. At this point, when we add another tenth, we're going to make 20/10. But notice, we have filled our second bar model. 20/10 is equal to 2 wholes, or just 2. Here's Greg. He's going to remind us of our key learnings today. The fraction tenths is made when a whole quantity is split into 10 equal parts. A whole amount is shown as 10/10. And Greg reminds us more than one whole amount can be shown as tenths. We just need to keep adding on the tenths. As always, you've worked through lots of examples relating to tenths today. I think you are ready to complete your independent task. Always come back and visit if you're unsure. For now, as always, good luck!